Namaskar, this is an online lecture video on solving ordinary differential equations of a three-dimensional nonlinear chaotic system in Simulink. The courses that will be benefited from this lecture video are control systems, electric drives, and relevant courses. The speaker is Monashita, Assistant Professor, Department of Electrical Engineering, Tezpur University, Ahom, India. So this is the integer order model of a permanent magnet synchronous generator or PMSG, which is a three-dimensional variable speed electric drive as shown in equation number 1. Three-dimensional meaning three state variables x1, x2 and x3. The denotations of the state variables x1, x2 and x3 and the parameters say 15 and 110 may be referred from reference 1 or in my previous videos. Now, if I want to find out the solutions or the outputs x1, x2 and x3, what do we have to do? We have to integrate this part. To get x1, we are going to integrate x1 dot, and that is why we're going to integrate this particular expression. Similarly, here I have written for all of the equations x1, x2 and x3. Now, how are we going to solve this in Simulink? Let us see. So, first you open Matlab and then you click on this Simulink icon. Okay. Then what will you get? You will get two windows like this one and this one. This one, how will you get? You click on File, New and Blank Model. Okay, I have just written the equations over here, otherwise you get a blank model. Then you click on this particular icon, Library Browser, and you're going to get the blocks. So here, in order to integrate all this part, what I'm going to do, I have to select an integrator, right? So, first of all, I will go to the Simulink library browser, click on commonly used blocks, and then click on the integrator like this. Okay. Then I can type out my initial condition. So, my initial condition for the first state variable is 1. Again, I can click on another integrator for x2 dot, that is. So, I'll put the initial condition as 1. Again, I can put the third integrator for integrating x3 dot. Let me put this as 100. Okay, so there are three integrators. Now, here what do we have? We have summation of two terms, 15x2 and minus 15x1. That means we will need a sum for this. So let me check in commonly used blocks as well. Yeah, this is a summer, so I'll drag it here. Then for the summation of these three terms, I will click on this and okay, let me first put on the signs. So here it is minus and plus. So I'll put here 1 minus and 1 plus. Okay, minus and plus. Then for the second equation, there's another summer. So how many signs are there? There are three signs, minus, minus and plus. So let me put it minus, plus, minus. And for the third part, x3 dot. Okay, so how many signs are there? Minus and plus. So let me put it plus and minus. Yes. So till here it's fine. For clarity, let me put on the name cell. Let me first begin naming. So I'll double click on this, create annotation. I'll put here this one is x1 dot say. Okay. Then let me increase the size of the font 14. Let me make it bold. Okay. Control C, Control V. Okay. Next, let me create another annotation here. Okay. So this will come here and I will rename it as x2. Okay. Now let me create another annotation here. It will be, so after integrating x1 dot, I shall get x1. So it will be x1. Let me increase the font size again, 14, bold. Okay. Now this one I can again copy and paste here. But I will have to make it 2. Okay. Similarly, copy and paste. Paste. This will be 3 because this is for the third equation. 3. Copy, paste. Paste. Now x1 dot, here the output x1 dot is a summation of 15x2 minus 15x1. That means x1 and x2 minus x1. So this one is minus sign here. So I'm going to connect it like this. Okay. But this 15 has to be there. So this 15 will be taken care of by a gain block. This one. Okay. I'll click and drag it here. Okay. The value of gain will be 15. 1, 5. Okay. Yeah. Again for x2, next is plus x2. So this plus sign will be connected to x2 over here. Again, I'll connect another gain term over here. It will be, the value will be 1, 5. Okay. Similarly for x2 dot is, we have minus x2. So let me connect the minus x2 here. Yeah. So the gain term is 1. So we don't need a gain block here. Then plus 10x1. So let me connect it here. Plus 10x1. Okay. But there is a gain term 110. So I will use a gain term. Okay. And the value is 110. 110. Now there is a third term over here, minus x1 and x3. So we will need a product block for this. So let me select in commonly used blocks, product. Yeah, this one is product. Okay. Yes. The product will consist of the multiplication of x1 and x3. So one will be x1 and another will be x3. Okay. Similarly, we do the connections for x3 dot as well. Okay, minus x3. So one point will be here, minus x3. Yeah, and the one is x1, x2, for which we'll need another product block. So here we have finished connecting all the blocks. As you can see, I'm scrolling down slowly so that you can see clearly. Okay, now I want to see the output. So what I can do, I can go to commonly used blocks again and select scope. Okay, now scope number of inputs would be x1. Okay, and you can also write x1. Okay, now what you can do, this will plot the values of x1 with respect to time. If you want to see the output x1 versus x2, what you can do, you can go to sinks. Okay, click on sinks and select xy graph over here. Okay, so one you connect it to x1, the other terminal you connect it to x2. Okay, then you click on this and change the limits. Let us make it 50 so that I can see the whole attractor. Plus 50, negative a lower limit of y-axis minus 50, upper limit of y-axis plus 50. Okay, now I can change the sample time as well, 0.01. If I make it smaller, the smoother the curve I will get. Okay. Now what I have done, I have renamed these blocks where I'm going to see the time series and the phase portrait. Now here on the scope, you can right click on the scope, signals and ports. Okay. Number of inputs 2. Okay, because I want to see both x1 and x2 across time axis. If I want to see x1, x2 and x3, I'm going to click on 3. Okay, so there are 2 ports. One is connected to x1, the another one is connected to x2. Now let me save and make the simulation time say around 100, and let us run and see what do we get. Yes, so this one is a time axis. The yellow one is the x1 series, blue one is the x2 series. If I connect one more input signal x3, I will get 3 time series, and this one is the attractor. This particular attractor is obtained from the xy graph. If I want to see the attractor between x2 and x3, I will have to connect it accordingly. So now let us see what we have the assignment as. The assignment is to make Simulink models of ordinary differential equations of nonlinear systems and to plot their phase portraits, that is x1 versus x2 or x2 versus x3. and the reference was this, from which we had taken the model of the permanent magnet synchronous generator. So for any query, you can always contact me, and these are my phone numbers. Then this is my email ID, official one. This is my personal email ID. So thank you.